Hi. There are a couple of things I want to tell you that live in chapter 15, but we're really not doing all of chapter 15. So this video is just to give you the couple of important things, and then maybe we'll even look at my Stat Lab homework together here. So I'm going to share my screen. I am in Paint here, and I copied over this problem that we had in the chapter 14 notes about number of absences and average final grade. I want to bring your attention to this point here where the average number of absences is 7 and the average final grade is 71.8. So I'm going to come on over here and find this point. There's that point right there. And I want to do on this graph, and maybe not be all that good with it, but I'll try. I'm going to try to show you graphically where y is, where y hat is, and the difference between y and y hat, which is our residual or error term. The residual is y minus y hat. Okay, so I'm going to choose black here. See if I can get it to, okay. And over here, this value, this, we actually see that it's 71.8, but I want to show it graphically. So I'm going to go straight across here. All right, and that's why. Right there. Okay, so this is the value of y, 71.8. And now I want to find y hat. So y hat is going to be if I take 7 and I go straight up to the line, that's going to be my value of y hat. So it's going to be right here. And I'll bring it straight across. Oops. Let's go ahead and choose the line here. So this is the fitted value of y. This is the value you'd get if you take 7 and put it into this equation. So we'll go ahead and label that as y hat. Okay, so this guy here is y, this guy here is y hat. So the vertical distance between y and y hat is your error term. It's how far off the actual value that the model would predict. And so we'll use the green bar here. And this vertical distance right here, that's our error term, y minus y hat. Okay, so for the data point that we're going to focus on, so this conversation's about just one data point, the data point 7, 71.8, y hat is going to be the fitted value. We saw it on the graph. It's the value at the line, at the regression line for x equals 7. And to get that numerically, we're going to substitute 7 into the regression equation. And that's 68.92. That's my y hat. So my error term, my residual, is going to be y minus y hat. 71.8 minus 68.92. Okay. and want to subtract. So my error term is 2.88. Let's go back to the screen, the notes that I was looking at there. And so what we have just done at the whiteboard is we know now that this green bar, which is our error associated with the data point when x equals 7, that the height of this, the length of this green bar is 2.88. So at times you will likely have to calculate a residual, maybe on an exam. So just, it's on the formula card. It's the last formula on the formula card. E equals y minus y hat. Okay, we can also graph these. Now, there's a couple of graphs that I want you to see in this course that I don't really expect you to create or interpret, but I do want to expose them to you to them, because in future classes, I believe that that would be really a benefit. So I have a regression analysis that I want to share and show you how we can make a graph of these individual residuals and how we interpret the graph. So this is a document on Blackboard, regression and residual analysis, and it has 1, 2, 3, 4, 5 different regression problems. I'm just going to start here with the first problem here. Let me just adjust the screen here. And what we have is, this is strength of concrete. And we have and concrete is poured, and the strength of the concrete is measured at 7 days and at 28 days. And so we're interested in this relationship between how well the 7-day, the strength at 7 days and the strength at 28 days. Okay, so these are our data points, and we look over here. This is our fitted line plot. And each of the values in each of the points in this fitted line plot has associated with it a residual, right? So is y, for example, the residual on this point here is y, which is somewhere up at around 4,900, minus y hat, which falls all the way down here, somewhere above 4,400. Okay, so this point here has that value associated with it. Y minus y hat's going to be kind of large and positive, because y is bigger than y hat. All the values up here are associated with positive residuals, and all the values down here are associated with negative residuals. And we have this one point here, which is either exactly on the line or almost on the line. And so this point here that has a 7-day strength and X value of about 2,900 has a residual really close to 0. So what we're going to do is I want to show you this plot of the residuals on the Y, and the X values, they stay the same. So let's kind of scooch over here. This is a residual plot. And we see this point here, which was right here. Okay. We see that point right there. And then here is this very large positive residual. Okay, and if I were to put in a horizontal line here, it might actually feel like this fitted line that was flattened out to become the residuals equal 0 line. So if you could take this regression line and flatten it out a little bit, like so, rotate it so that it becomes horizontal, then you're going to be shifting up then the residuals will be similar to the scatter plot, right? So we see here, this point is below the fitted line, and its residual is negative. And we can kind of go through, we see these two positives and over here, these two negatives. So this is a residual plot, and residual plots are a way of checking underlying assumptions in the regression model and whether or not those assumptions are met. So some of this sort of begins to move past the scope of the course, but I want to just show you a few things so you don't have to recognize patterns in residual plots. But I do want you to know that there are good patterns and bad patterns, and the residual plots are a tool for you to check on your regression analyses. So this is a nice residual plot. Over here, we have an analysis of wind speed and wind chill factor. Here is our data, and here is our fitted line. Okay, so what we see in a residual plot, in the residual plot, you see you have a positive residual and then negative residuals and then positives. So the residual plot actually here shows this pattern. And if you see a pattern in the residual plot, it means that there's a violation of the linearity. So there was a linearity assumption when we made the regression analysis. And in this case, you know, it's really not linear. You see this almost like it could be some, I don't know, part of a quadratic, or I'm not sure. I would have to think through what function this could better be than linear. Again, not something you have to do, but it's good to know that if you see this pattern, a pattern in the residuals, it means there's an absence of linearity. Notice here, we didn't really have a pattern in the residuals, so that's good. All right, so this looks like another pattern in the residuals. All right, let's go ahead, and there's a couple more things that this one here is per capita disposable income and per capita consumption. Definitely we have this, it looks like it's a really good linear relationship, but this point here seems to have a residual that's larger than all the other residuals. And how you would see that in a residual plot is that you might have one point that just has a larger absolute value, right? So this point is down here near minus 300, and all the other points are between minus 100 and 100. So that identifies, that's how you identify it. Maybe it's an outlier, you know, an outlying situation. All right, and then the final kind of residual plot that we might run into, or the final one that I'm going to bring up here today, is that if we look at this data, this is height and weight. I forget what this data set is. Let's look. Height and weight of these baseball players. Okay, and we come scroll down here and look at their height and weight. And what we see is that the residuals, like it seems like there's more variability for the shorter players and less variability as they get taller, okay? And one of the things, again, that we haven't really discussed in terms of assumptions of the linear model, just because this is an introductory course and we're just spending a little bit of time on regression, but I do want you to get a chance to hear it, is that the data that we like to have the variability around the line, around the regression line to be about the same, and that it should not be related to the value of the X variable. And this violates that because for values of smaller values of the X variable, we have large error terms, large residuals, and That's shown here. And as our height increases, the residuals decrease in size. So this is called a coning behavior. And this is, not that you need to know it, but violation of the constant error variance. Okay. So I just wanted you to see that. I'm going to take us over to my stat lab and look at, there's just 2 problems for chapter 15. I thought, why don't we just do it here on the video? Okay. So the difference between an observed value and a predicted value of the response variable is called the residual. Okay, oops. Nice work. Okay, let's go to the next question. Okay, and this is about the graph, okay? Which graph used in a residual analysis provides roughly the same information as the scatter plot, and what are its advantages over the scatter plot? So we're looking at residual plot, so it's going to be either B or C. Residual plot, that is a plot of the residuals against the values of their predictor variables, provides roughly the same information as the scatter plot. A residual plot makes it easier to spot patterns such as curvature and non-constant standard deviation, that easier to spot that than in a scatter plot. Okay, well, that one sounds really good. Let's look at this one about the residual plot. The residual plot, a plot of residuals against the values of the predictive variable, provides roughly the same information as the scatter plot. It provides no advantages. Well, I'm up with B here because we saw the advantages, right? It was easier for us to look at these violations of linearity, identify an outlier. It became a little easier on the residual plot. So I choose B. Oh, okay. All right, you guys. So I think that might be it for all the videos, but who knows? If there's anything else we need, I'll put a video together, and at any rate, I'll see you guys in class.